Good morning. I'm going to show you today how to make a speed conversion in Squeak Etoys. The reason we're doing this is to address this Common Core state standard. It's a 5th grade standard talking about converting between units. And this is being addressed in this following problem. Baseball players have been timing their sprints in feet per second and how fast they can run the bases. Yet pitchers measure their speeds in miles per hour. So they're speaking basically two different units, and it's hard to figure out. So we're going to develop a Squeak model that will help them convert from the speed of the pitch in miles per hour to feet per second. So to do this, we're going to need several pieces of text. This is going to be my miles per hour. This is my feet per second. And I really want to know the time, how long this takes. So this is going to be the pitch, miles per hour. This is going to be the pitch. This is basically going to be in feet per second. This is going to be the flight time. That's my flight time. Alright, so let's say the pitcher throws at 60 miles per hour. And I need to know how fast that's going to be in feet per second. So I'm going to call this feet per second. I'm going to call this miles per hour, or pitcher miles per hour. And this I'm going to change to pitcher feet per second. Okay, so I'm going to say, I'm going to open up the Halo and open up the viewer and say that the numeric value for the pitcher's feet per second, I want to calculate that. And I know from doing some simple math how to do this, but in case you don't, the math is down here. If I have X miles per hour, I know that 1 mile is 5,280 feet, 1 hour is 3,600 seconds, and this hour cancels with this hour, this mile cancels with this mile, and all I have left on the numerator are two numbers in feet, and the denominator I have 3,600 seconds. When I do that math, it'll help me calculate it. So basically I'm going to take my speed in miles per hour, multiply it by 5,280, and divide it by 3,600. So I need this number. Right now it's 60. I could type a 60 in there and I could go about finishing my equation. But what if they throw 61 miles per hour? This would be wrong. I have to come back in here and manually change this. So what I'm going to do is I'm going to open up the pitcher's miles per hour, and I'm going to take that numeric value. So whatever number is here, this equation will automatically work. So this is times 5,000, or multiplied by 5,280, and then divided by 3,600. Because I have 3,600 seconds in an hour. Now I don't need to put in parentheses here because according to the order of operations, multiplication is done in order from left to right, so this will always be correct. I'm going to make a button to fire this because that's just what I want to do. So if I fire that, it tells me that a 60 mile per hour pitch is 88 feet per second. So this equation works. Button works. I'm going to put it away. Now let's figure out how the flight time is. So I don't know, in order to have a flight time I need to know how fast I'm going, which I calculated here in feet per second, and I also have to know how far I'm going. And to do that, I can look right here, and I see that I'm going 60 feet from the pitcher's mound to the plate. So once again, these feet cancel with these feet, and all I have left are seconds. So if I multiply, or take my distance and divide it by my speed, it will tell me how long it is. So I could recreate all kinds of, oh, I'm sorry, yep, it's right here. So I'm going to call this pitch flight. I'm just going to P flight for pitch flight. And so there's that. I know my pitch is going 60.5 feet. And it's going to be divided by this 88 feet per second, or the pitcher's speed. In this script, because this number is never going to be a 0, I can just leave run. So calculating the pitch flight time. Oops. There we go. Nope, that's the one I want. This is what I want. And there it is. So my pitch flight time is 0.69 seconds at 60 miles per hour. Now that's only half the problem. We need to get back from the catcher's mitt all the way back to second base. Now, the first thing, catcher's throwing miles per hour as well. So I'm going to need to convert to feet per second, and then I have to calculate his flight time. Well, instead of redoing all the work, I could just make duplicates of all of these, because it's the same basic work, and just go in and change a few small things. So first of all, let's change this name. Oops. Instead of pitcher's mile per hour, let's call it catcher's mile per hour. I don't need that one, so I'm going to get rid of it. And instead of pitcher's feet per second, let's call it catcher's feet per second. And let's call this catcher's flight time. So my names are all right. I like that. Okay. So let's go ahead and calculate this. And look, the equation's already here. This says the catcher's feet per second, its numeric value, is the pitcher's miles per hour, numeric value, times 5,280 divided by 360. Well, it's not the pitcher's miles per hour, it's the catcher's miles per hour. So there's two things I could do. I could open this up and I could drag this out and drop it in here. You see how it highlights? Everything would work that way. A second way I could do it, in an easier way, is I could open up the halo and I could come to this tile right here, this circle here. It says make a tile. So I'm going to drop that right on here. See how it highlighted? Now this says the catcher's feet per second numeric value is the catcher's miles per hour numeric value multiplied by 5,280 divided by 360. Let's make a button to fire this. Let's test it. Let's change this to 100 miles per hour and calculate 146. Let's change this to 100 as well so we can check, because that should be the same. Excellent. Let's go back to 60. Let's go back to 60. Excellent. Okay, now that works. I want to slide that there, get it out of the way. Let's fix this equation. And right here it's up and it's running just like it was in the last one. This says the catcher's flight numeric value is 60.5 divided by pitcher's numeric value, pitcher's feet per second numeric value. And I don't want the pitcher's feet per second, I want the catcher's feet per second. So I'm going to do my little trick of just grabbing the tile. And let's change this to 100 and see if it works. 0.41. Let's change this to 100 and see if it works. Yes, everything works. There's one slight problem here, and it's a pretty important problem. This equation right here is for a distance of 60.5 feet. That's the distance from the pitcher's mound to home plate. So that's how fast the pitcher would, or the catcher would get it back to the pitcher, but not all the way to second base. So we need to figure out how far it is to second base. To do that, I'm going to come down here to math. I'm going to bring this up. So here's my baseball diamond, or a piece of it. It's 90 feet to first base and then 90 feet to second base. So I need to figure out how far the pitcher has to throw, or the catcher has to throw from home plate, whoopsie, all the way to second base. And we use Pythagorean's theorem for that. A squared, which is 90, plus b squared, which is 90, equals c squared. So I can figure that out, and it winds up being 127.3 feet. And you'll notice that it changed automatically here. Okay. Now this tells us the flight time from the pitcher's mound to home plate. This is from home plate to second base. We really need a total time though. Because that's how much time the baseman would have to run. And so my total time, it's a numeric value. I call this total time. The total times numeric value is going to be this numeric value, which is home plate to second base, plus this numeric value, which is the pitcher's mound to home plate. And those numbers will never be zero, so I can just let it run. Let's see. And as I change these numbers, let's go to 60. And you can see it changes automatically. Let's go to 90 mile an hour, throw for him. And 104 mile an hour fastball. So as we can see, the runner does not have a lot of time. Now this assumes that the catcher takes 0 time to mess with the ball between catching it and throwing it, which we know is not true. That can be up to 2 seconds. So if I had 2 seconds here, would it be reasonable for a baseman to run? That's almost 3 seconds. Well, let's just go with the worst case scenario, 1.3 seconds. People who run the 100-meter dash run it in about 10 seconds, let's say. So that's 10 meters per second. So you have 1.3 seconds, which is about 10 meters, 30 feet. That's going to be tight. Alright, thank you.